For this final problem, we see that we have a square root on both sides. So because each side has a square root that's isolated, so there's nothing outside of it besides. It's just the square root and an equal sign. We can go ahead and square both sides. So I'm going to raise both sides of the problem to the second power. Because squaring is the opposite of the square root function. So these two things are going to cancel each other out, and you'll just be left with what's underneath, which is 2x plus 5. On the right side, same thing happens. Squaring undoes the square root, so these will cancel out, and you'll just be left with what's underneath, which is x plus 7. And so now I have a nice linear equation to solve. So I get all my x's together on one side. So I get x plus 5 equals 7. I subtract 5 from both sides, and I get x equals 2. And then you want to check your answer to make sure it works and that it's not extraneous. So you plug it in place of the x on both sides and simplify to see if you really do get the same thing on both sides of your equation. So on the left, 2 times 2 is 4, so I'm going to have 4 plus 5 under my square root. On the right, 2 plus 7 is 9, so I have 9 underneath. So on the left, I get the square root of 9. On the right, I've got the square root of 9, which is 3, so both sides come out to equal 3, and it checks. I don't have an extraneous solution. This really is our answer to that problem.